In a modern stadium, an elite athlete can launch a metal spear nearly 90 meters with a single motion. It is the only event in track and field that still utilizes a weapon originally designed for the prehistoric battlefield. For most of human history, the goal of this technology was simple: refine the aerodynamics to ensure the point traveled as far as physically possible. But look at the records from the late 1980s. You'll see a sudden, sharp decline in throwing distances. The governing bodies of the sport intentionally intervened, altering the equipment so it would fly shorter distances. It seems counterintuitive. Why would a sport dedicated to the pursuit of distance deliberately handicap the very tool used to achieve it? Solving that mystery requires tracing the Javelin's path from a primal survival tool to a highly regulated instrument of physics. Early humans relied on entirely wooden or bone-tipped spears like this one. They were lethal tools, engineered for the high-stakes reality of hunting and tribal warfare. By 708 BC, the ancient Greeks had integrated the throw into the Olympic pentathlon, testing both the distance of the launch and the accuracy of the strike. During this era, athletes developed the ankle, a specialized leather strap wrapped around the shaft. This strap acted as a mechanical lever. As the javelin left the hand, the leather would unwind, generating a rapid rotational spin that stabilized the spear mid-flight, much like a modern bullet. After centuries of use in European military combat, the javelin was eventually reclaimed as a standardized athletic event by Sweden and Finland in the 19th century. This era established the modern rules we recognize today, leading to the javelin's Olympic debut for men in 1908 and women in 1932. A period defined by the dominance of Finnish throwers. Standardized rules pushed the focus toward the absolute limits of human strength and material durability. By the mid-20th century, heavy wood gave way to lightweight, aerodynamic metal alloys. These new materials were so effective that javelins began to overfly the designated landing sectors. They were traveling so far, they threatened the safety of spectators and officials at the opposite end of the stadium. Furthermore, these highly aerodynamic shafts tended to glide and land flat on the turf. Without a clear tip impact, judges found it nearly impossible to mark an accurate distance. To fix this, the 1986 redesign moved the javelin's center of gravity forward by 4 centimeters. This forward-weighted design forced the nose to pitch downward earlier in the flight, effectively killing the gliding effect and shortening the total distance. This ensured that the spear could consistently land tip first, providing the clear, measurable impact the judges needed, while keeping the throws within the safety of the stadium walls. This shift meant the sport's technical standards were now dictated by the practical needs of the stadium environment, rather than the singular pursuit of distance. After the redesign, athletes could no longer rely on equipment that naturally floated through the air. Throwers had to adapt, using advanced biomechanical analysis and specialized strength training to generate the raw physical power needed to hurl the heavier-nosed javelin. This focus on human optimization worked. Despite the less aerodynamic equipment, elite modern throwers have once again pushed past the 90-meter mark. As video analysis and biomechanical data became more accessible globally, the training secrets once held by European programs began to spread. This democratization of sports science has led to the rise of world-class contenders from Asia and Africa, who now challenge for the Olympic podium. It is a remarkable journey for a simple tool that began as a sharpened survival branch. Today, the javelin remains a link to our earliest ancestors, now refined by modern physics and the absolute limits of human athleticism.